Because uniformly distributed loads occur so frequently, there are tables out there you can use to select what type of beam to use in certain situations. This is an example of one of those tables from the text, but as you can see, it's not the easiest thing to read. I'm going to show you how to create your own table using Excel without much effort. So here's the one I created. Using that same chart I have in the previous assignments, I added these two new columns for the maximum load and the deflection. So, and then on another tab I have this calculator, and then on another tab the example. So in the example it had a uniform distributed load of 40 kips or 40,000 pounds with a beam length of 18. So if I put those numbers in my calculator over here, and you can see my chart over here started updating. Anything in red I can't use, so right here you can see that this beam type would work for that situation. So I'm going to show you how I accomplish this. So first, to start off with the max load column, this is the formula I'm using. So what I did is I looked through all of our equations we have. Let's switch over here and try to find out what equations I could use to solve for that max load per beam type. So what I'm solving for is weight. So I looked through what equations I had that had weight included in it. And because this is a uniformly distributed load on this beam, I found this equation. M maximum moment equals weight times length divided by 8. So I know length, that was in that one particular situation, that was 18 feet. 8's a constant, but I don't know my maximum moment. So looking through more equations, what are some of my other knowns? I found I'm going to use our section modulus equals M over allowable bending stress, FB, because I have FB right here because we're using that A36 steel, so that's 24,000 psi, and I know per type of beam I have my section modulus right here. So now the only unknown, if I combine everything together, is the weight right here. So I'll show you how I did that. So let's take S equals, I'm going to substitute this M with this equation here, so that's W times length divided by 8 divided by FB. Now I'm solving for W, so I need to move all that over. So I'm going to multiply this side by FB and then that side by FB. So now I have S times FB equals WL divided by 8 and times this side by 8. That cancels that out. Now S times FB times 8 equals weight times length. Now last step, divide that by length and length. So S section modulus times FB times 8 divided by L equals weight. And that looks like crap, but that works. Alright. So that's the equation I'm going to put in that cell here, and then have it just fill out the rest going from cell to cell. Okay, let's see here. On my calculator here, remember a while ago, let's see here, it's in under your formulas. Yeah, the formulas tab here, you can do define names. So I named each of these cells. I called it AUL underscore E. You can call it whatever you want. The AUL is allowable uniform load, and then whatever underscore E was, that's your modulus of elasticity, and so on and so forth. So now those will always remain constant through all these cells. So if you look at my equation here, I have S, which is this cell, times my FB, which is over here, but I typed in the AUL. When you get the name in there, when you start typing, it will actually start popping up those different names you have. So you just double click on them and it puts it there. This one's divided by 12 because we have to keep in mind our units. This is let's think here. So I'm going to convert this from inches to feet, times 8 divided by length, because length is in feet here, and then divide the whole thing by 1,000 because I want these to show up in kips. So there's that. And then in this cell, that's the deflection equation you did in the previous exercise. That's the 5 divided by 384 times weight times length to the third divided by your modulus of elasticity times your moment of inertia. And then depending on how you do this, I've had it just automatically fill out. Let's see if I can, let's try this on a new row. So if I hit enter and press equals, I think that one was, okay, so that's gonna be our S. So yeah, when it fills out with this naming structure, it should just populate the whole cell once I'm done. So that's times AUL FB, double click, divided by 12 times 8 parenthesis divided by my length, so AUL L, double click, parenthesis, and then all of that divided by 1,000. Yep, see, then all you have to do is that one cell and it fills out the entire chart for you. The other thing I have going on here is this conditional formatting. So if any of these cells are less than our weight we have here, it's going to color them in red. So then you can quickly see just at a glance which ones won't work for whatever you're trying to, whatever situation you have. So to do that, you can select, let me see here, let's undo, I'm going to clear the formatting on this one real quick. Okay, so up here in our home tab, conditional formatting, click here, highlight cell rules. I want any cell less than this guy to, well, here's the automatic. You have different options for how you want it to be filled in. That's fine. Yep, so now this did this incorrectly. One second, what happened here? Oh, that's right. I have to throw another equation in there. This less than, click here, and then divide that by 1,000 because that's in pounds. Press enter. Light red with dark red text is fine. Say OK. And now it did exactly what I had over here. I went in and made mine that dark red instead of the light pink, but that's your own preference. And then I'm going to delete this now. Okay, so now if we run through our example over here, from the book, like I said, it was 40,000 pounds on an 18-foot beam. I filled that out in my calculator, and I went over here, and I see that the lightest beam that doesn't have any red cells on it is going to be this 16 by 31. Click on the example, click on the drop down, and find 16 by 31, which is right here. And then you're done. And if you ever need to try something else, it should just automatically populate your chart. So let's say from problem 514A, it's got 36,000 pounds on it, and it was, oh, that one was 18 feet too. Oh, I'm changing the wrong spot. It's right here in our calculator. Press enter, and looks like we could use this 14 by 30 on that from that problem. If you look back at your assignment on that one, I do believe that matches up. Alright, that's all I got. If you want to open your different tabs and different windows, which is kind of helpful with that calculator we're using, you can go to, let's see here, View, and New Window. And it doesn't seem like it did anything, but if I go View, and I'm going to want 3 of them, so I'm going to do New Window again, and then go Arrange All, and we'll want them tiled. So now I can have my example tab on, say, this window, and my calculator up on this window. So when I'm changing things, I don't have to keep going back and forth between the different 29. The different tabs. Just kind of a convenient thing. You can do it if you want. If you don't, whatever.